Welcome to 6WIND's vRouter webinar. Today's topic is border router solutions for internet service providers. My name is Kelly LeBlanc. I run 6WIND's marketing program and am based in Santa Clara, California. Joining me is Jan Rappaport, 6WIND's VP of Product Management. Jan will give a demo of our border router use case. We reserved plenty of time for Q&A after the demo. Please enter your questions using the Q&A button at the bottom of your screen, and we will answer them in the order that they are received. Now let's start with a quick introduction of 6WIND. 6WIND is a software company headquartered in France with offices around the world, including Santa Clara, California, and Beijing, China. We make high-performance networking software with deep expertise in telecom. In recognition of our innovation, we received an investment from Cisco and a vRouter Innovators Award from IDC. From those of you in the developers community, you may know us as the founders of dpdk.org and a top contributor. Here's an overview of our software product portfolio. Our initial flagship product, 6WIND Gate, is a complete Layer 2 through Layer 4 networking stack, available in source code form factor optimized for standard commercial off-the-shelf servers, including x86 and ARM architectures. 6WIND Gate is integrated by OEM vendors to develop a complete networking appliance, solution, or system. 6WIND Gate is used to build 6WIND's vRouter software solutions. 6WIND Virtual Accelerator is a vRouter that fulfills all the requirements to power the hypervisor with the necessary features for virtual networking infrastructure used in network function virtualization infrastructure, data center virtualization, or network appliance virtualization use cases. 6WIND Turbo Router, Turbo IPsec, and Turbo CGNAT are vRouters in the form of software appliances that lead the market with a performance advantage. Popular use cases include border routers, IPsec VPN gateways and concentrators, security for mobile infrastructure, carrier-grade NAT, and more. Here is a list of some of our key customers, many of which are brand names in the networking and applications market. OEMs such as Cisco, Nokia, NEC, Mavenir, Nuage, and many others have been using our 6WIND Gate source code to build their own products for over a decade. Service providers and enterprises such as Arbor Networks, AT&T, and OVH use our vRouters to build their networks and services. You may have read the news in Fierce Telecom and SDX Central and a nice blog from CME Corp that 6WIND has been announcing a lot of ISP customer wins for our border vRouter use case recently. For these use cases, we've replaced hardware border routers with vRouters on Intel-based servers. In today's webinar, we will start with an overview of our vRouter, then we will introduce our border router use case. Jan will demonstrate our border vRouter in a configuration that is running live in our customers' networks today. Then we've left plenty of time for Q&A. 6WIND's vRouter has been replacing hardware border routers with software on white box servers for several years now. We are able to do this thanks to our performance, features, and management. For performance, we support millions of routes, including up to 4 full internet routing tables, which is only limited by the memory in your system. We leverage multi-core processors with our multi-threaded software to deliver industry-leading convergence times, and our performance scales linearly with each CPU core added to the implementation. We deliver the complete border router feature set, including advanced techniques for DDoS attack protection, and our management is state-of-the-art. 6WIND's vRouter allows you to build a range of border router solutions on commercial off-the-shelf servers with the same software. We support a range of powerful Intel CPUs, from the Atom processor all the way up to the latest Xeon scalable processors and 1 to 100 gig NICs. You can run our vRouter on top of Linux KVM, VMware ESXi, and AWS VMs today. VirtIO, VMXNet3, and SRIOV are supported. Many of you already have Intel-based servers from one of these leading vendors, so you are ready to go. Just download our software, and you can have a router with 1 to 100 gigs of throughput performance according to your requirements. If you are purchasing servers for your deployment, you have a wide range of options and flexibility for bare metal or virtual machine deployments. We license our software with 1 gig to 100 gig options. 6WIND vRouter provides both traditional CLI-based management and IT-style management based on automation and integration with high-level orchestration tools. For this, 6WIND vRouter proposes a Yang-based netconf API. Configuration can happen through the CLI and netconf API for integration with third-party management tools and orchestrators. Our data models leverage Yang and are therefore easily understandable and extensible. For deployment, we provide packaged images for bare metal, KVM, VMware, and AWS, and leverage the Linux Cloud Init features that enable the customization of day one configuration at startup, including initial networking configuration, default users, custom software packages, and configuration files. Finally, for monitoring, we support the traditional SNMP and syslog mechanisms, plus telemetry through SFlow and graphical analytics with time series database. We have pre-integrated the vRouter with InfluxDB and Grafana, which are standard open source time series database and analytics software. Our integration and default Grafana dashboards are available on GitHub for the community to download and extend. Now for our border router use case. Here we represent an ISP network with its access, services, and core network blocks. ISPs interconnect with each other and agree to exchange traffic across separate networks, joining many networks into a single one so that their customers can reach any device on the internet. Interconnection is done in POPs or through internet exchange points thanks to border routers. At the end of this presentation, Jan will show a demo that outlines the main requirements of ISP border routers and explain how 6WIND's vRouter fulfills them, providing a cost-effective white box solution. We call border routers the routers at the border of the ISP's backbone. They connect to transit routers that are actually border routers of other ISPs. A border router is typically replicated on the ISP network for redundancy and connected to several transit routers for network optimization. Depending on the ISP's size, scalability and throughput requirements vary. It is common for a border router to handle 10 gigabits per second of routing, multiple BGP full routes due to redundancy, and BGP multi-homing. BGP convergence time is also a critical item. Regarding networking features, eBGP is used to exchange routes between ISPs networks. Towards the ISP backbone, iBGP is used to announce the routes learned from other ISPs, to optimize routing paths and avoid unnecessary traffic. BGP policies and filtering are required on the border router. Border routers are also usually set up in a redundant way so that if a border router fails, traffic is redirected to the other one. Finally, the border router is integrated into the ISP's management system. Therefore, it must provide APIs for configuration and monitoring of the routing information. 6WIND's vRouter meets these requirements with a significant software advantage. Here's a summary of our border router solution before we start the demo. Depending on their size, ISPs require high throughput per border router, up to hundreds of gigabits per second and more, and a very large number of routes. 6WIND's vRouter software is designed for performance, leveraging the DPDK for IOs and 6WIND's networking stack for packet processing, reaching a forwarding performance of 12 million packets per second per Intel Xeon core, or more than 15 gigabits per second per core with 136 byte packets, which is the expected packet size in this environment. This performance scales with the number of cores assigned to the vRouter. BGP scalability is only limited by the amount of available memory in the system, so that handling multiple BGP full routes is not a problem. And we leverage the power of Intel cores to ensure fast convergence. The vRouter supports IPv4 and IPv6 external and internal routing protocols with BGP4 and BGP4 Plus and OSPF-E2 and OSPF-E3. BGP allows for a first level of routing optimization using AS path depth. Intelligent routing platforms can optimize the routing paths even further by analyzing the global network traffic on the backbone and using BGP flow spec to inject specific policy-based routes to reach a specific destination. ACLs and reverse path filtering are also supported to prevent unwanted traffic to pollute the backbone. In terms of management, the vRouter supports configuration and monitoring APIs for integration with the ISPs management and orchestration framework. The NetComp standard is supported for configuration and granular monitoring. And for more advanced visualization features, the vRouter can export KPIs to a time series database coupled with analytic software. A well-known example is the pair InfluxDB Grafana, with which the vRouter is pre-integrated. With that, now it's time for our demo, and I will hand it over to Jan.
Thank you, Kelly. I will now start our border router demo. This schema represents the backbone of an ISP with the core routers in the green area in the center and some border routers in the blue areas on the left and the right. Let's focus on one of the border sites. 6WIND vRouter will run on the border routers. They are usually redundant. The border routers are connected to border routers of other ISPs, and these ISPs themselves are connected to other ISPs, forming the internet. eBGP is used with the transit routers to exchange external routing information, and iBGP and OSPF are used with the core network to propagate the routes. We will use an Ixia traffic generator to simulate the internet traffic at 20 gigabit per second. Let's start by reviewing the IP configuration of the different interfaces. A lag interface is used towards the PE routers in the core to provide active standby high availability with the redundant border routers. The traffic towards each of the transit routers is encapsulated in VLANs. We use a loopback interface for iBGP. And now let's review the BGP configuration. Here we see the iBGP peerings with the PE routers, as well as the eBGP peerings with the transit routers. And finally, the iBGP peerings with the other border router for high availability and the intelligent routing platform for routing optimization through BGP flow spec. OSPF is used internally to learn the IP addresses used for iBGP with the PE routers and the other border router. Now let's review the BGP state. In the BGP summary view, we see the BGP full routes learned from the transit routers and from the other border router. There are 4 full routes configured in the system and 1.3 million RIB entries. Commands are available to review the routes advertised to a specific router, here to the transit router towards ISP1, And conversely, we can see the routes received from this same router. There are a lot of them as we receive the BGP full route from this router. Let's now review the monitoring and analytics mechanisms used in this demo. The vRouter is connected to the ISP's EMS. We can review the configuration of the KPIs that are retrieved from the system and sent to the time series database of the EMS. These include product information, such as license and version, system information, such as CPU or memory usage, networking statistics, and others. These KPIs are periodically exported to an InfluxDB time series database and will be displayed in a Grafana dashboard, as we will see in a few seconds. And for the data plane statistics, sFlow is used to export data plane samples to the EMS. This information will be used to chart how the traffic towards diverse destinations is dispatched among the different transit routers. We can dump traffic on the core network to see the sFlow v5 packets toward the EMS. Now, let's simulate some traffic towards Netflix, YouTube, and the rest of the internet. We use an Ixia traffic generator for that, and we generate 20 gigabit per second of traffic. In the Grafana dashboard of the EMS, we can see how the KPIs are displayed for continuous monitoring of the system. We see system uptime, vRouter status, memory and CPU usage, network interfaces with their throughputs. We also see process and users information. We see disk usage and IPv4 neighbors and routes configured in the system. We can see that 700,000 routes are installed in the FIB. Regarding network traffic analysis, the AS stats dashboard is filled in thanks to the sFlow information. We see 3 graphs according to the destination of the traffic, and the colors indicate the transit router used to reach that destination. We can see that YouTube is reached through transit 1 in pink, Netflix through transit 2 in light blue, and the rest of the internet through transit 3 in dark blue. It's now time to optimize network traffic. As we have seen, traffic to YouTube goes through ISP1, traffic to Netflix through ISP2, and traffic to the rest of the internet through ISP3 according to BGP and AS path selection. At some point, the IRP detects that it is more optimal to reach the internet through ISP1 compared to the path that was originally selected by BGP. BGP flow spec is used to alter the RIB into the vRouter using policy-based routing. As a result, the traffic towards the internet starts flowing through ISP1. Let's review the BGP flow spec functionality that allows for network optimization. We can see the state on the vRouter on the left when no flow spec information has been received yet. On the IRP, we will use the EXA-BGP tool to send the flow spec rule to the vRouter, asking to redirect the flow with destination 8.8.8.0/24 that simulates the internet traffic through transit router 1. We can see on the vRouter that a BGP flow spec prefix has been learned, and that this translates into an ACL and a policy-based routing rule that will take precedence over the routing path that was computed by BGP. To conclude, let's check the AS stats dashboard. we can see that the traffic towards the rest of the internet now goes through transit 1, as the pink color in the first graph indicates. And this concludes our demo. So we've just seen how our vRouter solves ISPs challenges for industry-leading performance, software scalability, features, and next-generation management for their border router use cases. It's ready to deploy today on your existing Intel-based servers. For customers transitioning from proprietary hardware routers to a white box strategy, you have many server options to choose from. And now you've seen some powerful examples of customers who have successfully made the transition to 6WIND vRouters. Thank you for watching our demo. We reserve plenty of time for your questions. Now back to Kelly to open the Q&A.
Thank you, Jan. That was an excellent demo. Now we'll open it up for Q&A. And as a reminder, please enter your questions using the Q&A button at the bottom of your screen, and we'll answer them in the order that they are received. So we've received quite a few questions. We're going to try and get through these all. Let's start at the top. Okay, the first question we have, how do I get started on an eval?
Sure, so to get started on your eval, you will start by requesting the eval from our website evaluation form, and you will receive the software for testing. By the way, those of you who attend today will receive an email with the evaluation software link as a special thanks. So we support Intel Xeon family, including E5, E7, scalable. We support Atom C3000 based servers. So you just need one of those servers and make sure that there are at least 2 cores and 8 gig of RAM available if you want to test scalability. We provide binaries in different formats depending on your installation. So you can install via a USB device or CD-ROM on a bare metal system. Or we provide also ready-to-use VM images, OVA, QCO, or ISO. Installing the image is really straightforward, and you'll be logged into the CLI in a few minutes.
Great, thank you. Next question. What virtual machines do you support?
So you can run the vRouter on top of Linux KVM, on top of VMware ESXi, and Amazon Web Services. We support Virtio, VMXNet3 Virtual NICs, and we also support SRIOV or pass-through. As a reminder, you can also run bare metal, of course.
Okay, the next question. What kind of hardware do I need? I think Jan answered that in how do I get started. So as a reminder, you can run our vRouter on any Intel Xeon, E5, E7, or scalable family processor, or the Intel Atom C3000 processor-based server. All right, next question. Can you support multiple full BGP tables?
Yes, so we have validated up to 4 full internet tables with our customers. So they deploy our solution with 4 full internet tables. Actually, in theory, we can support more, as it's only dependent upon the memory in the system, starting at 8 GB for 1 full table.
Okay, next question. Can you converge quickly?
Of course, actually the implementation is multi-threaded. It scales with the number of processor cores assigned to your use case. Plus, with the support for multiple full internet tables, it allows us to converge quickly. So what we heard from our customers is that we have leading convergence times in the industry.
Okay, next question. How do I manage your vRouter remotely?
So you can log into the CLI using SSH. So that's for, I would say, human interaction with the system. And to automate the configuration and for programmatic environment, we support netconfig. So you can plug your netconfig compatible orchestration or management tool remotely. So for example, it can be Ansible, it can be some proprietary or open source management tools. As long as netconfig is supported and it's a standard, it will work programmatically.
Okay, next up, do you support DDoS protection?
Yes, so we provide DDoS protection through features like BGP flow spec, where it's you will divert traffic to a black hole to prevent attacks, and learning filtering rules through BGP, for example.
Okay, next, have you integrated with any management frameworks?
Sure. So our historical customers, Nokia and NEC, for example, they have integrated and deployed our technology with their management frameworks. So it's been done for decades. More recently, with our binary products, we have pre-validated for monitoring with InfluxDB and Grafana. We have a GitHub with a lot of information about it that explains how to deploy the vRouter with InfluxDB and Grafana. We work very regularly with customers integrating with Nagios. So for SNMP, and also using the InfluxDB APIs through a Nagios plugin. And regarding orchestration, so we've seen miscellaneous deployments, so using open source, using commercial environments, so that includes VMware, OpenStack, OpenDaylight. We've worked with our partners Cloudify, Nuage, of course, from Nokia, Contron, and more.
Excellent. Okay, the next question is about our CLI. So is there a CLI learning curve?
So we provide a quite industry standard CLI. It comes with traditional features like completion, history, contextual help. So that's very useful to get familiar with the CLI. Our CLI relies on the Yang data model. It's a client for the netconf engine. And actually, one of the unique features is that you can browse the data model as you browse a file system. So you can use a ... and you navigate through the data model as in a file system. So it's quite convenient when you get started with our CLI. You can use relative and absolute path to refer to configuration data. So that's also very interesting and efficient. And finally, we include configuration commit with rollback on error and simultaneous access with the ability to compare configurations in case it's been modified in between. You're able to see what's been modified and merge it into your configuration before you commit it. As I said, it's a netconf client, so everything you can do with the CLI, you can also do it through our netconfig API in an automatic and programmatic way.
Okay. Another question coming in. Do I need any specific NICs to run the vRouter on a bare metal server?
So we support many kinds of NICs. So from Intel, so all Intel Niantic's NICs, Mellanox NICs as well are supported. We support most of the NICs of the market for bare metal deployment. And for virtual deployment, the same NICs are supported through SIRV or pass-through, plus the virtual NICs, Virtio and VMXNet3. And sorry, I was going to forget Amazon and AWS ENA.
Okay, great. We have time for one more question, so we'll take this one. What platform did you use in your webinar demo?
So for this demo, we were quite reasonable. We used a 20 gig vRouter. It was running as a VM on an Intel Xeon E5 CPU. It's a 2690 V3, 2.6 gig, with some Intel 8259 10 gig NICs in pass-through. So with that, we got our 20 gigabit per second of performance, our 4 full routes configured in the system. But actually, we could have run the same demo on Intel C3000, for example. Of course, the performance would have been lower, or we could have run it on a scalable Platinum processor for higher performance requirements. What's important is that The data plane performance scales with the number of CPU cores, and the control plane performance scales with system memory. So that allows our customers to build a range of solutions according to their requirements, and all this with the same software.
Okay, that's it for the questions. So thank you all for your questions. Our Q&A session is now closed. For more information, please visit the Border Router page on our website. Here you will find our Border Router deployment guide to help you quickly get started. You will also find Intel's new solution brief on 6WIND vRouter solutions for service providers. And for those of you live on the webinar today, I will send you our vRouter software to evaluate for your Border Router use case as a special thanks. This concludes our webinar. Thank you for joining us. If you have any additional questions, please don't hesitate to contact me directly. I'm happy to help. We look forward to hearing from you soon. Bye for now.